All right, welcome everybody. So in this video, I want to continue our initial exploration of the storms data set in the dplyr package in R. So we're continuing from a previous video. The link to this Colab document is up here, but it's long. I will provide a link in the description of this video. If you want these commands to work in this video, just keep in mind that you need to first load the dplyr package. So be sure you run this line of code. If you get a little dialog below, don't worry. This line of code should run just fine. That dialog does not mean that there was an error. And now that we've loaded the dplyr package, you'll be able to work with the storms data set. And so if you just want to check to make sure you've got that loaded, we can run this line of code to get a summary of storms that we talked about in the first video. And the main thing I want to address in this video is this issue with category. So category would be like category 1 hurricane, category 2 hurricane, and so on. So although where the values of category are numbers 1, 2, 3, 4, and 5, this is actually a categorical variable. We would like to count up how many storms were category 1 and how many storms were category 2. So we would like this variable category to work similar to the status variable in the storms data set, which is encoded as a factor, which means status is being treated as a categorical variable, and we're getting the counts for each type of storm as opposed to something like a mean or a median. Let's pick up over here with the assignment to new or existing objects. So we're going to run some lines of code below. And in R, the way that we assign a new object is by typing a left angle bracket followed by a hyphen. So it's a series of 2 symbols. So we use this as an assignment in R, the left angle hyphen, and we don't really use the equal sign for assignment. So if you've coded in Python, we use equal signs. Just one change to note here with R is that we use a different symbol or symbols for assignment. And so we're working with the storms data set, which contains 13 different variables in an array, which is called the data frame. So each row is a different observation, and each column corresponds to a different variable, a different characteristic that we record for the storm. And oftentimes we don't want to work with the entire data set. We might just want to limit our focus to one variable. And that means rather than work with the entire data frame, we would like to just pull off the data in one column and store that data in that one column to a separate vector. So that's what's called extracting a variable. And so there are different ways that we can extract information from a data frame. One really nice way to do so is using a $. And for example, if I want to pull off just the wind speeds for all of the observations in the storms data set, then I can type first the data frame name, which is storms, followed by a $, and then the name of the variable, which in this case is wind. So this will pull off just the wind column in the storms data frame, and it will save those values to a vector. So down here, I've got a code cell, which is going to exactly do that. So I've got 2 lines of code here. The first line of code is taking the wind column in the storms data frame and saving all of those values to a vector that I call W. And this second line of code is going to calculate the mean value of all of those wind speeds. So the mean being the average value. So we can calculate the average wind speed, and it's going to take that average wind speed and store it to an object that I call xbar.w. I'm going to run this line of code. I get a green check mark, which means this line of code ran correctly. However, you might be disappointed that you don't see any output printed to the screen. And so we haven't told R to print that output to the screen. So these programming languages tend to be very, very literal. So if we want to see that output, we need to instruct R to print that output to the screen. And the way that we can do that is just by writing the name of the object. So in this case, xbar.w, this is telling R to print whatever is stored in xbar.w, show that on the screen. And here I can see that that is like 50.0174 and so on. So this is giving me the average wind speed in knots. And if I want to do the assignment, so I want to do a calculation and assign it to some object and then print that value to the screen, we can do that all within the same code cell. For example, here I'm calculating the maximum wind speed, and this wind is actually not a defined thing. We defined wind as W, so I need to correct that. So max W is going to calculate the maximum wind speed. It's going to store that in this object called wind max, and then my next line of code is actually printing that to the screen. And I can see the maximum wind speed is 165 knots. Another way that you can both assign a value to an object and print that object to the screen is by putting the object inside of parentheses. So first I'm calculating the minimum wind speed with what I've highlighted. And notice I've got a pair of parentheses enclosing that command. And that means whatever is inside those parentheses is going to be printed to the screen. So here I can see the minimum wind speed was 10 knots. And one last code cell that I want to walk through just to illustrate that we can do multiple commands within the same code cell. We don't need to do just one or two commands at a time. Here I'm working with storm pressures. So I went ahead and pulled off, extracted the pressure variable and stored those pressures to a vector that I'm calling P. I can calculate the maximum storm pressure and store that in P max. I can calculate the minimum storm pressure and store that in P min. And then I can calculate the difference between the maximum and minimum pressures. And that's called the range of the pressure. I'm going to assign that value to the range of P. And then finally, if I want to see what that value is, I need to print it to the screen. So running this line of code or this code cell executes all of these lines of code. And what's printed to the screen is the range, which is the difference. How much distance is there between the minimum and maximum storm pressures in this data set? Kind of the main takeaways so far are when we do assignment in R, we type these two characters, the left angle and a hyphen. And when we want to pull off a variable, one variable from a data frame, we can do that using this $sign convention. Okay, so we've been working with wind and pressure. Those are numeric variables, but there are kind of 6 basic data types in R, the most common data types that are listed out below. We've seen characters such as the storm name. We've seen that some of the variables were being stored as decimals. Some were being stored as integers. And there are logicals and complex and raw data types as well. So one really useful way to play around and check different data types is to use the typeof function. So the typeof function will tell us what data type the thing inside the parentheses is. So I'm going to run this code cell and we can kind of check the output to make sure it makes sense. The number 1.0, that is a decimal. The number 2, by default, when I enter a number, is it treats it as a decimal. And so if I want to store something as an integer, notice I need to put an L after the number. So 3L is the integer 3. 2 is the decimal 2.000, so on. When we type character strings, we need to type them in between quotes. So I can't just type hello, but I type hello inside of quotes, and that's read as a character. And then true is a logical. Notice that true is in all capitals. So the logicals are written in all caps, true and false. Okay, so one way to play around and check what sort of data type we're working with is the typeof function. That output is going to tell us what type of data, what data type that object is. The is dot whatever, for example, is.numeric, is.integer, is.character, is.factor, these are a logical test. And so if x is numeric, the output is going to be true. If this object x is not numeric, then the output is false. It won't tell me what x is. It's just telling me whether or not x is a certain data type. So in this code cell below, we can check out year and name. So yes, year was being stored as a numeric, so we can see that over here. Storm name was being stored as a character, and so that's why we get a true as the output of that command. And running these three commands, we can see that status, that was like hurricane, tropical storm, etc. That variable is not numeric. That variable is not a character, although the values are characters. The status variable is being stored as a factor, meaning it's being stored as a categorical variable. So we can see that is true. And if we're kind of curious about, well, what exactly are the different classes of the storm status, I can use the structure command and run structure storm status, and this is telling me that there are 9 different levels of storm status. Okay, and so the variable that we want to convert is this category variable, like what category hurricane are we? And the categories are 1, 2, 3, 4, and 5. And although those categories are numbers, we actually want to treat that as a categorical variable and count up how many storms fall in each of those categories. So here we can just double check. I would like category to be stored as a factor. Initially, it is not being stored as a factor. It is being stored as a numeric. So I would like to change the data type of category from numeric to factor. That's my task. And the way that I can do that is using the factor function. So here, if we take a look at category, again, remember, this is being stored as a numeric. So the summary that I'm getting is a numeric summary. And what would be more helpful would be to get the counts of how many storms occurred in each of those 5 categories. So the way that I can convert category to a factor is using this command factor. So I just say factor in the dataset storms, the variable category, and then I can save this result to anything at all that I want. But what I want to do is override the current category variable with a new category variable where they're being stored as factors. So I'm going to convert category to a factor, and then I'm going to assign this to storms category. Storms category already exists, so it's going to overwrite that column in the data frame. So it's going to have the same values, just being stored as a different data type. So this first line of code here is converting category to a factor and overwriting it and storing it back in the same spot in the category column of storms. And this next column is going to give me the resulting summary of that result. And you can see I get a different summary than I had above. So up above is when category was being treated as a numeric variable. Now I can see that I've successfully converted category to a categorical factor variable, and it's counting 2,478 storms were category 1 hurricanes. 973 were category 2 hurricanes, and so on. So that's how we can convert something which is not categorical, a numeric variable, we can convert it to being stored as a categorical variable. And we can convert other data types as well. So if I want to convert to a numeric or an integer or a character, then we use the command as whatever the data type is, and then we input the thing that we want to change. So for example, both year and month initially in the storms data set were being stored as decimals. But year and month are just integer values. So if we want to clean that up and store each of these as an integer, I can do as integer storms year. That's going to convert year from a decimal to an integer and then override it in the year column in storms. And here I'm going to convert month from a decimal to an integer. And I don't see any output from this code cell because all I've done is assigned things, but I haven't printed anything to the screen. And so if I want to check whether or not these converted properly, I can use the typeof function. And now I can see that after running this previous code cell, year has been converted from a double, from a decimal to an integer, and month has also been converted from a decimal to an integer. Okay, so that is a wrap of this example working with storms data. I just want to point out that for your quiz, you're going to be working with a different data set, and you might want to start a totally brand new Colab document. So I want to just let you know how you can create a new Colab document and how you can set it up to run in R. So if I want to create a new notebook, I just say File, New Notebook. Great. Now I've got a blank Colab document that is in my drive. And by default, this is really important. Colab runs Python. So I want to change the run type from Python to R. So let me just kind of show you again what I did. I just clicked on this arrow next to connect. I pick change runtime type, and I change it to R. And now my Colab document is running R code. And you're going to want to access a data set, which is called diamonds, to work on your quiz. And that diamonds data set lives in the package ggplot2. So I'm going to do a library ggplot2. So I'm going to run this ggplot2 command. That seems to have run correctly, so I can tell that I am running R. And here I could do like a summary diamonds. And you can see that there is a diamonds data set that exists inside ggplot. And on your quiz, you're going to need to answer some questions about the variables in this data set. All right, thanks a lot, everybody.